Okay, so Git. So a lot of the tools that we're going to be looking at in this course is how is that we're going to collaborate with one another, right? And Git is by far one of the more common source control tools that allow you to share source code, right? Ideally, we don't want to be just when are we working on a source code, we don't want to be trampling on each other, right? Oftentimes, we're going to be working on the same file, and I don't want you overriding my code. So you want to make sure that whatever changes we make to a source is not going to conflict between us, right? Git is one of several source control tools. It's what we refer to as a distributed source control, meaning there is no one single place that is the repository. It is not. I mean, we typically decide that one particular repository we're going to make it the one single source of truth, but it's not mandated by Git, right? Git basically works on everybody having their own repository, and then at some point making sure that we're all in sync, right? And that we're going to deploy a particular version of the repository of our version of files. It's a tool that allows us to manage the evolution of a file, right? We might have various versions of the same file as a project evolves, right? We might be refactoring, we might be splitting a large file into smaller files, we might be making changes as new features come in, as we fix bugs, as we improve performance. We might have many different versions of the same exact file, and it evolves over time. And not only for ourselves, but also especially when we are working in teams. Oftentimes, we're going to be working together in the same feature. And again, we want to make sure that whatever changes you make are not overriding my changes, and we need to be able to synchronize and merge together those changes. So certainly to be able to manage the lifespan of an entire file, but also to collaborate, right? It's one of the main mechanisms for collaboration. And again, this course is all about collaborating. So the more common way of doing this source control is to have a single place that we refer to as a centralized repository that contains all the files. And then every one of us is responsible for letting everybody know that, hey, I'm touching this file. Don't work there because I'm working there. Typically, this is done through some kind of locking mechanism, right? We lock the file. I am working on it. I make changes, and then I put it back, right? And if you want to work on it, you need to wait until I unlock the file so that you can then work on it, lock it, and work on your own, right? So this is the common way of source control that other tools such as CBS, SVN uses this model, right? Git is a little bit different. It's what is referred to as a distributed version control, right? So we all start with a copy of perhaps of the same repository, and then we decide to collaborate and clone either my version or your version, and then we can make changes to it. I can then propose that my changes you merge into your repository, right? And then there might be conflicts that we need to resolve, and at some point we need to agree, whose repository is eventually going to be deployed, right? What is the source of truth? Typically, we decide that some centralized remote repository we bless it as the center, the V1 source of truth, right? That it's the one that we are eventually going to deploy. Also, the way Git keeps track of things that are changed, it only keeps track of what has been modified, right? Giving an original version of a file, right? It keeps track of which lines were added, which lines were removed, which lines were modified over time, and the cumulative history of those changes is what transform an original file into what the current version is. Okay, so it doesn't. We don't keep. Git doesn't keep the snapshots of the same file over time. Instead, it keeps track of changes over time. Right, that cumulative transform a file into what it is today. So there is no centralized repository. It's only we decide as part of the process that we're going to be following. We decide that one particular repository is going to be the centralized repository. So it's not mandated by Git. Git works on defining three distinct areas that we work on. Certainly, there's the current file system that you're working on, right? That's where you might create new files. You might be editing new files using your favorite IDE, and all these new files. We say that until you don't let Git know, Git will report as saying, well, all these new files, I don't know what they're doing. I'm not tracking them. I don't know if they're changing. I don't know what you're doing with these files. So what we call it the working area, where we create files, modify files, and up until we don't tell Git these are files in this working area, we consider them to be untracked. And then when we notify Git, hey, I've created these new files, or I've made these changes, and we add them to Git, and then Git moves into what is conceptually referred to as a staging area, right? Where now any changes that you might be making will start being tracked, right? Once you're happy with those changes, then you can then commit and make those changes permanent and put it in the repository. Okay, so it goes from the working area to a staging area and then to a repository. Okay, at any one of these stages, there are alternatives or different ways that you can undo certain things, right? Obviously, until you haven't yet told Git to make this anything permanent, it is the easiest place to make those immediate changes, right? If you created a file and maybe you didn't give it a good name, or the content has something wrong, this is the easiest place to make those changes in the working area. Once you start committing and making those changes more permanent, it becomes more and more challenging, right, to undo anything that you might have done. Okay, so today we'll talk about various alternatives, right? And depending on how far have you made your changes permanent, what are the various strategies and alternatives and consequences, right, of making changes going forward. Also, Git all by itself is not much, right? It's just a mechanism for maintaining history and maintaining different versions. Its value of any source control in general is when is used in conjunction with a process, right? And where it typically is used for code review, right? Where you're making changes, you're submitting your source code, and then somebody else is assigned to look at your source code, right? And then critique it, right? And say, well, what do you think, right? And there might be several back and forth between you and the rest of the team that might be providing some feedback, telling you, why did you do it this way? Why didn't you do it this other way? Or it might be letting you know some consequences that you weren't aware of. Okay, so certainly the value of source control is when it's used in a process of source becoming part of a larger thing, right? Source code. Remember that when you generate source code, you're not coding for yourself, right? The code is certainly going to outlive you. It's certainly going to be somebody else's responsibility, right? So it's a team effort, right? Any source that you might be creating, eventually somebody else is gonna have to maintain that, right? So Git or source control in general, when used in this process of accountability, right? Where everybody's open to positive criticism. That the source code is everybody's. Everybody takes ownership of their source code, and that we are open to critique and to just improve the source code, and that it's a team effort, not to take things personally, right? When folks are giving us feedback or giving us some critiques, to understand that it is all part of the process. Yes. Eventually, somebody's going to take responsibility of the source code. It's going to review it. It's going to accept it, right? And when somebody accepts it, or somebody else in the team accepts it, they're saying, "Hey, I'm willing to take responsibility for the source code." Meaning, once you leave this team, I'm going to make myself responsible for the source code, right? So you would be in that same role as well. Somebody else might ask you to review the source code, right? And you are going to have to provide some feedback and let them know if you are willing to make yourself responsible for that source code, right? That if something is broken or there are bugs or anything, you might be the one who's fixing this, right? So make sure that as part of the process, the source eventually makes itself to be permanent, and it makes it harder to make any modifications later on. All right. So here's the life cycle of files as they are being created and being modified. You create brand new files, and they are in a state that is referred to as untracked, meaning any changes that you make to that file, Git would not wouldn't know what's going on, right? You can change it as much as you want until you add those files. Is when you're telling Git, "Hey Git, I want you to start tracking any changes to this file," right? And then any subsequent changes that you make to those files, the Git is maintaining a log of what is going on. What are the transformations to those files that would recreate the current version from previous versions. Once you edit the file, you can then move it to a staging area, right? And again, as you proceed towards the repository, it becomes more permanent up until you ask Git to commit those changes and make them permanent. Now, it might be that it's just not one file. It might be that you're creating several files, or you're editing a set of files. That set of changes, right, is what gets eventually committed as one change set that gets committed into the repository. So remember, what gets committed are the changes, right, not the files themselves. Right? Well, obviously, the very first time you create a file, the change is the entire file. Yes, but from there on, the actual changes that get committed are how that original file goes through the changes, change sets that transform it into the current version. Once it's committed, other folks in the team can then pull or clone those changes, those files that have been committed, and they can start participating in the same process. Right? They can clone down from that repository, make changes, and then propose those changes to the team to be reviewed and then eventually made permanent. Okay. If you have a Mac, Git should be already installed on your machines. If you have never run Git, and you do run Git from the command line, you might get a message saying that you might need to install certain Xcode tools, right? And accept that. It's going to start downloading some Xcode and install some of those command line tools on your environment. If instead you have a Windows machine, you'll need to download from Git SCM, download their command line tool. Or if you have a favorite Git client, then you can use that as well, right? I particularly like SourceTree, although is there SourceTree for Windows? No, is there? Yeah. Yes.
So I was looking ahead of homework, and one of the things we have to turn in is a transcript of our session.
Yes.
But if we're using like the Emacs Git client,
true. Yeah, for this very first assignment, you're asked to do everything from the command line.
Okay.
Yeah. So we want you to have just a minimum familiarity and feel confidence just by using the plain old command line. Once you feel confident with that, then by all means go on and use your favorite Git client. All right? Or you might have it side by side just to make sure that the tree is what you expect it to be the state of the tree, right? But for us to be able to verify and grade.
Yeah. Fine with that. I was just curious as you said.
No. For this first assignment, we'll learn the multiplication tables, and then you can use the calculator. Okay. All right. Yeah. So this is going to install a bash command line tool that is going to allow you to do Linux-style commands, right? That to create or rename files or move files around. And including all the Git commands. All right. So please, if you have if you're a Mac, you should already be all set. If you're a PC, you'll need to install your this Git bash. All right. All right. So let's get started. Once you install Git, Git will install a couple of configuration files in your home directory on Windows. It'll be your user directory. On a Mac, it typically will be the tilde home directory. And in there, it'll install a git config file that will have your default login credentials, right? What's your username and what your email is to authenticate with the with Git. Okay. And also, when you create a brand new project, it'll also create a local config file under a hidden directory called .git. Like .git. If you want to be able to see it, you'll need to do an ls-LA to be able to see that file. And you can configure, you can change various configuration elements, such as change your username, change your credentials, change the text editor that you use, if you're using VI or Emacs or whatever, for interacting with Git files. So, for instance, from my command line, so if we are at the, so here you should be able to find git config. There it is, and we can just look at it. Git config says that my email is jnunzi. My name is evajones@gmail. It has some global configuration files. My command, I believe. Okay, yeah, I'm using source tree as my my Git client. What else? We have some global. We have the Git ignore. A global. So Git ignore is another file that allows us to set up files that are just irrelevant, right? As we interact and with Git, and we generate files. Oftentimes there are many files that we really don't care to put in source control, right? Perhaps there are several configuration files or object compilation files, or just library files, right? Jar files, lots of class files that don't make sense to put in source control. Or files that can be generated at deployment time, right? All those files don't make sense to put them in source control. Also, there are certain files that the operating system creates. Here we have, notice on git ignore, .gitignore, is declaring that we don't want to put anything that is temporary files, like all the files that Windows generates, right? Word or Excel, right? They generate a whole bunch of tilde documents. Meaning those we don't want to track, right? We don't want to keep track of those. Also, on Macs, Macs create all these DS store files, right? So we don't want to deal with those either. But there are many other files that we want to ignore depending on your particular project, right? If you have a Java project, typically you want to ignore the .class files, right? If it's a Node.js project, typically anything under node_modules, right? You don't want to put that in source control either. So depending on your project, right, there might be many different files that you want to ignore, right? So you can either add them here in git ignore global, or you can have a .git ignore in your particular project, okay? And we'll play around with that a little bit later. Okay. All right. So let's create a little directory where we can play around with some of the more common git commands. Let's see, where are we? So let's go into NEU and let's make a directory git example or git demo. And right now it's just bless you. Right now it's just any folder like any other folder. So there's nothing special about this particular folder. But we're going to initialize it. We're going to say git space init. I don't know if you can see that. I'm going blind, so. Now it says that it has initialized this repository, and if you now look at the content of this repository, we'll see that it has added a new directory in there called .git. It's a hidden directory, and that's where Git does all its work. Right? That's how This is how Git is going to keep track of everything we do, all the source that we generate, and any changes that we make. We can see the content of Git. All right, we see that in there we have a couple of files. You should not change anything here, right? This is where Git does its own things. You have a local configuration, right, where you can set up different logins, right? If you want to, if this particular repository is logging into some other repository, right? So you could have different projects deploying to different repositories, right? So this is where you can override. If you don't override anything here, it'll just use the global configuration, your global email to log in to remote repositories. Also here, it keeps track of what it's called the head. Head is a reference to the current history, right, or the beginning of the current history of all the changes that you've made. Currently, we haven't made anything. We haven't made any change. So head is really not pointing to anything. It's like a linked list, right, where you have a pointer that points to the beginning of the list. Yes, and internally it has its own structure where every change that you make, right, it adds a brand new node, right, and then each node points to the previous node, right? So that, and then it updates the head to point to the brand new node. Yes, right. And with the structure, it allows you to walk the structure, right? Because it's a singly linked list. You can start at the head and then just follow along. What are the history of all the changes that you've made so far? Make sense? So head is just a file that points to the current node, and there is no node because we haven't made any change. We haven't added any files whatsoever just yet. Okay. Anyway, okay, there are no files. Let's keep working. Let's see. Right. So this directory is where. This directory is what makes this a Git repository, a local Git repository. If I blow away this Git directory, then this will no longer be a Git repository. All right, this one single .git file is what makes this particular directory a repository. All right, so if I blow it away, then there's no Git. All right, so let's start with playing around with a couple things. Again, we're going to do everything at the command line, and in the assignment, you will be asked to please do everything at the command line, so that the TAs can then very easily just walk through all the history of what you've done so far and grade you. After if you feel comfortable with using a a user interface to deal a client. So feel free to use that to just follow along and verify that all your changes is what you expect. All right, so let's create our very first file. So echo, what names are we using here? Okay, echo my very first file, and we're gonna send it over to file1.txt. And now if I ls, obviously my new file is there, file1.txt. Yes. And if I ask Git, hey Git, what do you think of this file? I can always ask Git, what is my current status, right? What do you know of what's going on, right? If I say Git status, it says, hey, there's this brand new file, file1.txt. I see that there's a brand new file on the directory, and I don't know anything about this file. Right? This is an untracked file. Okay, I see that it's brand new. Do you want me to track it? Right? Do you want me to start tracking changes to this file? And to do that, we can use. Notice that it gives us some help here. That if you do want to start tracking this file, you can add it. You can say git add, and then the name of the file. Right? Meaning you can add just one single file. Or if you have created several files, you can add them all in a single instance. You can say git add dot. It'll add all the files, or a single individual file. So we can add this one, git add, and then file1.txt. Once we've added it, right, and we can notice that the file hasn't changed. It's still there, file1.txt. We can still ask for git status again, right? And it says, ooh, now I know about this file. And now I'm tracking any changes that you made to this file, but it hasn't been committed, right? Meaning any of these changes are not yet permanent, right? If you blow away this file, I don't know, I don't have a history of it, right? You have to make it permanent so that this file becomes available to everybody else, and that you're starting keeping track of a history of this file. Make sense? All right. So we've added the brand new file, and now is part of being tracked. So yeah, so git status is a command that allows you to keep track of what's going on, right? Of what is Git aware of any files that might be untracked. So whenever in doubt, always ask git status, right? And it'll tell you where what does Git think about the current status of this project. Also notice another thing that Git is reporting is that we are currently in the master branch, right? The master branch, right? We'll see also a little later that it's very important to be able to as you are working in adding new features or making changes to those features, we have to make sure that we keep track of what we consider to be the latest stable version of the system, right, of our source, right? So that as we progress in making changes, we don't inadvertently, right, introduce more problems into the system. We might fix one bug, but somehow introduce two bugs. So that's certainly, we don't want to do that. So branches, as we'll see a little later, allows us to create alternative universes, right? Alternative spaces for us to work off something that's very close to what the original was, but it allows us to let me try something, right? And once I feel comfortable and I've run all my tests and it passes all muster, right? So we can then perhaps make those changes permanent and put it back into the master branch. Make sense? So certainly we'll talk about a little later that it is best practice, right, to not ever just work on the master branch, right? Is to instead create separate what we call feature branches, right? And do all your work on your feature branch, and once you're comfortable, then merge it back into the master. Or go a little further and say, and not even merge it into the master, you would push it into a global remote repository, right? And have other folks look at it, right? And what you do is you ask or you request someone else to take a look at this, and you ask it to, hey, when you look at what do you think about this change? And if they accept it, then we merge it back into master. Yes? Obviously, creating all these branches introduces some risk that, especially in bigger teams, that I'm working on my branch and you're working in that other branch, and we are somewhat diverging, right, away from the true branch, right, the master branch. So it could be that the versions of our branches are diverging in such a way that when we do merge back into the master branch, we might have conflicts. Yes. So certainly we need to deal with how do we deal with that of dealing with those conflicts. So right now it's just me working on the master branch, right? And we'll introduce branching a little later, right? Right now we just have the default master branch, and that's where we're working. All right, so we have created our very first file, and we are currently working on our master branch. So before I make any of my changes, permanent, I still have alternatives, right, or options to to undo my changes, right? I might decide that, oh no, actually I didn't mean to do that, right? And that's Git gives us a lot of possibilities and tools to always undo or go back to my previous state. Right? How do I throw away my changes because I just ran into I painted myself into a corner? Right? It says, can we just go back to where we were a minute ago? And typically what we want to do is make sure that every little step that we make, right, we have tests, right, to verify that our change hasn't broken anything, right? We'll talk about testing a little later, but certainly those would be already in place. We don't have that. We don't have any of those just yet. And ideally, every change that we make, we would be running tests that would tell us, right, that hey, we just broke something, right, and we would like to be able to undo or go back to a previous stable state. One of the mechanisms is that we can ask Git to clean. We can say Git clean, and we can ask it what would be removed. Right? Clean allows us to remove files that have not yet been committed, that have not yet been made permanent. We can ask it, hey, what would be removed? Right now we haven't committed anything, so nothing would be removed. Did I commit this? Git status. I still have that. Git status. We added those files, right? Wait, did we commit earlier? Oh, we didn't commit, right? Right, so we can commit, make those changes permanent. We can say git commit. Now, right now we've already added the file, right? And committing tells Git that this new files that we've added, we want to make them permanent, right? And put them in the repository for other folks to use them. And the command is just called commit, right? And typically we want to provide some useful message, right? That would very succinctly describe what it is that we did. Right? Ideally, the comment that we would add here would be descriptive enough that folks can understand very quickly what you did without actually looking at the source code. Right? Obviously, they can find out what we did by looking at the files that we created. But ideally, my changes would be so small, right, and to the point that I should be able to describe in a single sentence what is it that I did. Right? So I created file1.txt. Right? Typically, they should start with a verb, right? And each team might have various standards on what this text should be. Typically, it should be what we would put in like a subject line on an email, right? If you'd like to be able to send somebody an email, perhaps the message of the email should be, or the theme of the email would be succinctly summarized in one single subject line, right? So that somebody can very quickly see whether they want to even read your email. So anyway, so those changes were made and made permanent. And if we ask for status, notice that it'll say that there's nothing new, right? That one file was created, it was added permanently to my repository, and there is nothing new to report, right? Our file is still there. There's nothing changed here, but the .git file, the Git repository has been updated to keep track of any changes that you might have made. We can always look at a history of what we have done so far by asking for the log. You can say git log, and git log will display the message, right? The exact message that we added that describes that particular commit. It'll also display who committed it. And notice that right now it's just me on that same repository, but later on when you're going to be working in projects, certainly will be 2, 3, 4, 5 different folks who are going to be committing to that same repository, right? So this will say the email of the person who committed it and when it was committed, and also we have here a unique identifier that uniquely represents this one single commit. And typically this is a calculated ID, right, that takes the entire content of the file and it calculates a hash, right, that uniquely represents that one commit. Okay. Or you can have a shorter version of this, right? Just a created file 1.txt. Okay. All right. Right. So not everything should be tracked, as we mentioned a little earlier. Like files that change very often. For instance, obviously databases, as you insert, as you update, as you remove things from the database, the files that are used by the database change so often. They're not worth putting in source control. You might the only exception might be if you are providing SQL files that might recreate the initial state of a database. Those might be those could be tracked in source control, right? That set up initial set of users, initial set of domain objects, right? Initial set of relationship between those objects that would insert dummy data or test data into a database, right? So that makes sense to insert into a database. At least the SQL instructions to recreate the database, right? So that certainly is a good thing to put in a database. Also, temporary files that your tools generate. For instance, your IDE is going to generate lots of XML preferences files, and none of that makes sense to put in source control, right? That's typically if you have your own particular local environment, right? Your environment, your IDE, your database, your tools are going to generate lots of temporary files that makes no sense to put in source control. Certainly compile or library files that or data that is generated for testing purposes. None of that should be added to the source control. So make sure that none of that ever makes it to your source control. And the way we handle that is by managing the git ignore file, right? Which we looked at we look at the global git ignore file, but there is a local git ignore file that you can create to make sure that certain files never make it to source control. Okay, so let's play around with .git ignore. For instance, right now we don't have one. We don't have a git ignore. Let's create a git ignore. Notice that let's first create another file. Let's see. We can create echo ignore me. Ignore this file, and we're going to send it over to a file called ignore me. And so as far as so there's the file ignore.me. As far as Git is concerned, we'll see that we see that Git is reporting that there is this brand new file ignore.me that is not currently in repository. Right? It's not there. I don't know anything about it, and but we might decide that all files that end in .me should be ignored. Right? So, for instance, to do that, we can create our own .git ignore. So let's create a .git ignore. So echo. We're going to echo that everything that ends with the .me. Is going to be, it needs to be ignored, meaning do not put it in source control. So we'll put it in a file called git ignore. Right? So right now we have those two files, the ignore me and this brand new git ignore. If we now ask git again, what does it think about our repository? Notice that it no longer is reporting. It no longer is reporting that my new file ignore.me as a untracked file. See that? It's saying I'm not even looking at it. Right? I'm not even considering it. Instead, it sees that there's this brand new file, the .git ignore itself. It's a new file in the repository. Right? So that we'll need to add to source control. So let's we'll say git add .git ignore. Right? And do a git status again. And there it is. It's ready to be committed and made permanent. So let's add it. We'll say git commit. Now this command here, the commit command. Notice that we're first adding the file and then we are committing our changes. Yes, you can combine the two into one single step. Right. So instead of just putting the message here, you could put ANN. Right. Meaning add all the files that we want to add to the repository, and also add the following comment. Okay, so you can combine those two steps, the git add and the git commit, into one single by adding the -a in front of it. Yes? Right. So here we might say so added git ignore file. Right. So we can also do a git log again, and we see that we have two commits, right? And notice that in reverse chronological order. Right? This is the latest one first. Notice that each one has its own unique identifier, a SHA here that uniquely identifies that particular commit, or you can have a more abbreviated. A single line description of all the commits that you've done so far, right? So only those two. We first created the file, and then we added the git ignore file. But notice that our file is still there. Notice that our ignore.me is still there, right? It's not that it went anywhere. But when other folks clone this repository and bring it down, that git ignore is not going to be there. They're not going to see it. Okay. There's only a file that makes sense in my local repository. Perhaps I'm using one IDE and somebody else is using another IDE. Yes? So in my local system, I'll have preference files and for my particular IDE that you shouldn't care about, right? And in your local file, you'll also have files that for your particular IDE in your own environment. Also for running local tests, you might have different configuration files depending on the environment. You might have some configuration files to test the system locally, and you might have configuration files for testing it in QA, or testing it in production, or testing it in staging. Yes? So none of those files, all right, those files should only live in those environments. Yes? And depending on those environments, it'll test it against different databases, against different services, against different remote resources, right? And those files only mean anything on that particular environment. So those are typically things that are, again, not put in source control. All right? All right. Right, so this is git ignore. I think we did this, right? Yes. Right, so once you feel comfortable with your changes, like we did, we need to make those changes permanent, right? Moving those changes from the staging area and move them over to the actual repository. Right? And the way we do that is to use the commit command with a very descriptive message. Right? Again, this is meant to be so that folks don't actually need to read the source code. Right? That 3 weeks from now or next year, if I look at that commit, we might come back to this and say, ooh. I think I fixed that, a couple months ago. Let me look up my history. Yes, and by looking at my history, I should be able to very quickly understand that. Ooh, it was that commit, right? Once I find it, I can then look into my details of what actually source file I changed, and perhaps revisit my fix. So yeah, so please, the TAs are going to look for this, right? As you're working in your project, the TAs are going to be reading all your commits, all your messages, right? And making sure that you are providing useful commit messages, and they might penalize it for you if you don't have meaningful commits, all right? So make sure that you have those very useful commit messages. Right, so commit messages matter. Keep them to a size that again, something that you would be okay with putting in a subject line. So anything below 50 characters, don't get too verbose. Typically, when you're using other tools, it allows you to add many more lines. But it's good practice to keep it short, right? Short and sweet. Right. So right, we want to make sure that those messages, right, are easy for us to be able to reconstitute or be able to reestablish the state of a particular system, right? So if we as we are committing and we have a history of those commits, we should be able to have that our commits put the system from one stable state to a next stable state, right? That it never leaves the system in a unstable state, right? So you never would commit something that would break the system, right? That you should be able to jump around, right, between the different commits and always have a working, stable system, right? It could be that you are committing changes, right, and that you like to be able to backtrack, right, into your commit history, right? At any one point, you should have the end result should be a stable system. Also, the name and the commit message should be clear enough that it's predictable what's going to happen, right, if you do jump around between your commits, right? That you'd be going back to a commit that would have those changes that is what you would expect. So we want to make sure that it makes it easy for us to be able to reestablish a particular context, right, of where the application was and any particular history. Okay. So here are some best practices on commit messages. To keep it short, under 50 characters. Although if you should consider it as being the subject line in an email. You can, some tools allow you to go much more than 50 characters. And if you use the correct white spaces, it will format it as if it were an email, right? It'll grab the first line of your comment as a subject line, and it'll grab the rest of your commit as the body of an email, right? And even format it for you, where you can add bullet points, you can bold and some very simple formatting that then can be used elsewhere in other clients, right? And folks can then very easily see the documentation of your particular commit, right? But usually your commit should be simple enough and small enough that you can summarize it in a single line. We don't want to see is large commits. Usually the rule of thumb is that you should commit small things frequently. Right? If you now the sizes of your commits, we'll leave it up to you. But typically you shouldn't be committing more than 3 files, and perhaps within those files you should not have more than a dozen lines of code that in that one file. Right? We don't want to see huge commits where you have dozens of files. Yes.
So isn't the desire for atomic commits, right, where like each commit is a stable system, and the desire to have really tiny commits, aren't those a lot of tension? I mean, because if you're making big changes, right, maybe you need to make 200 lines of changes. You're gonna like somehow make them in tiny little 12-line steps.
Right. So ideally, your implementation would be self-contained, modular, right? That you would be creating services that you're not using until, right? So it depends, right? If you have a top-down design or a bottom-up design, right? Where those are modular, self-contained, right? And the dependencies are very well defined. And so you're not you're not having lots of query, lots of SQL access and then services all in one single place, but you have modular pieces of it, right? Where you can then build larger complex code in terms of smaller reusable pieces of it, right? So that's the intention, right? Later on when we look at test-driven design, you would first create the test, right? And then any code that you additionally add to the system would be designed to pass that test, right? And the test would be small enough and self-contained enough that should be small, should be tiny. I mean, that's the intent. Obviously, there will be some exceptions, right, where you might have a lot of mock data, right, that you might be including that test a temporary state of the application that might put your application in a particular state. Those typically, a lot of DAT files and JSON files or XML files. Probably those certainly those might make sense, right? Certainly images and all sorts of those would be large commits, right? Certainly binary files as well, right? But the intention is to in a day-to-day, right? You would have frequent commits, small commits, and sporadic large commits where everybody in the team agrees that it is that is okay, right? Right. So once you do your commit, the Git will generate a unique identifier, a 40-digit hexadecimal number that will uniquely identify your commits. Right? That can then be used. Can then be used to jump around. Right? If you ever want to undo or jump to a particular state of your application, that you could use that unique identifier to jump between different versions of your of the state of the application, right? So here's a graphical representation, a diagram of what I mentioned earlier of this singly linked list that represents the history of your commit. At first, when there were no files whatsoever, we see that the head is a reference was not referencing anything because there were no files. as the history of your files, as you create new files, as you modify those files, new commits are represented as node in this diagram, and each one of these nodes represents a particular commit, right, with a unique identifier. And that commit might entail having added certain files, modified certain files, but represented here by a single unique identifier. And as you move forward in time, the head is then updated to point to the very latest commit, right? And we have these linked lists where each one of these commits refers to the previous commit, so that you can traverse these commits forwards and backwards with these pointers. Okay, and then we'll see later that you can move this head, right, and jump around, right, and reset it at different points in the tree. Right now we only have one branch, right? We have just one single master branch, but typically, in a well trafficked source tree, you might have lots of branches branching off of the main master branch, and then at some point you're coming back and merging back into the master branch, right? You can see all these feature branches where folks are making their local works and then making it available for the rest of the team. Right now, we can take a look at the at head, and we can ask for .git. Where am I? Git ignore cat.git. We have references, heads, master. Okay, notice that this is pointing, has a value here that is the hexadecimal value of the current commit that the head is referring to. So it's referring to the very latest. If we do a git log, we'll see that the very latest one, right, is indeed that value we saw earlier, right? It ends with AE54. So it's this one. So the head is pointing to this very last commit that we introduced just a minute earlier. Okay. Right. So yeah. So we can list the history of the various commits by using the log command, as we have been doing so far. And you can add all sorts of filters to make so that if you have a very long history of commands, you can filter it by starting a particular date, 1 month ago and until 1 day ago. It has all these. It can parse several of these sentences and map them to actual timestamps, right? So that it can filter any log history that falls between those two dates. You can start since, until, that were committed by a particular author, or you can even grep, if you're looking for a particular keyword in that in the message of the commit, or you can ask it for one line, so that you don't want the entire. You just want to summarize a single liner that describes only the message of the commit. All right. So yeah. So git log is very useful. You can also ask for differences, meaning what has changed from the last time that I modified this right, and say, I've made these changes, these files, and I started yesterday, and I forgot to commit, and I want to come back to where I was. What has changed since the last time that I touched this, right? And so what git diff is going to do is going to compare your files with the whatever is currently in the repository, whatever the head is pointing to, right? So it'll go through your file and compare it against what's there. If you modify several files, it'll iterate over all the files that you've touched, right, and give you a report on what has changed with all these files. So let's maybe create a file. What names are they giving us? Okay, let's do file 1. Let's I don't know. Let's create file 2. Echo file2.txt, and we'll put here my first line in file 2. Okay, and according to Git, I'm status. Okay, so there's this file, and so let's commit this file first. We'll do git git commit. Both will add and add the comment. So this is added file to.txt to demo diff. Oh, I haven't added. Sorry, I'm sorry. First it has to be added the very first time, right? After that, once it has the very first time, we can then just add afterwards using the -am. So let's add all of them. Git the file number 2, and this has added file 2.txt, and let's commit that. Where's my commit? All right. So now we don't have anything else, and let's change now file number 2. So we'll have we now have file number 2, and let's add a second line. So we'll say maybe echo. This is my second line, and we'll add it to file2.txt. And we'll notice that we can look at file number 2. We have those two lines, and we can ask Git to give us a difference, right? What's the difference between what's in the file and what's already in there, and what has changed? So it tells me that I have added, notice the plus sign that says that I have added my second line, right, in that file. Notice that it gives me the content and tells me where the changes have started, right? And notice that my first line is just plain old white. If I would have removed a line of code, then it would have shown it with a minus and in red, highlighted in red, what has been removed. So let's we can make those changes permanent. Oh, do we want to make it? Do we want to make the changes right now or not? Not yet. Okay. If the changes is in a file that has been added but not yet committed, we can also make those comparisons as well. Right now we're comparing with what it's in head, right? But we can also compare to things that have been staged but not yet made permanent. So let's push this along. So let's do a commit changed file 2.txt to demo diff. Right, git status. Okay, so we've made those changes permanent. So what about comparing things that are in stage? So if we create a second file, so file to demo diff with stage. So and we'll put it in file 3. And right now we're just going to put it in staging. So we can say git add file 3. So now it's in staging, or git status, and we can make changes to this. Say we can do we can echo second line in file 3, and we add it to file3.txt, and we can do a git diff. And we can compare with things that are in staging. So we can say stage. Is it stage? Staged. Right, so it's now comparing to what we have put in staging. So depending on what is that you want to compare with, compare it against what is in head, or compare it to something that is in stage. Right. So anyway, so let's commit this. So git commit am added file 3 to demo diff stage. All right. All right. So let's see. Let's keep going. We can also remove files, right? So and removing files that are being tracked, right? The Git is gonna realize that you have removed this file, and it depends when you remove it. It'll report it a little bit differently. So for instance here, let's see. Let's add a temporary file here. So echo temporary file, and we'll put it in temp1. And we'll actually 2 temporary files. So let's do temp2, temporary file number 2. And if we ask Git for a status, it'll say that there's these 2 new files that are not yet being tracked. So let's add both of them. Let's add both. So git add dot, right, just adds everything that has not yet been staged. So if we look at status, it'll ask us these 2 brand new files. Let's commit this. Let's commit this and then try to remove one of them, right, and see what's going on, right? So we do a git commit, added temp files to demo remove. Right, so they're being added, and there's nothing new in our local repository. If we start removing things, if you say rm temp1, right? If we start removing it, and then we ask Git, well, what do you think about that? It realizes that indeed this file has been removed, but has been removed locally, right? Not in the repo. The repo still knows about temp1, right? Not until we make this change permanent, not until we commit, then it will be actually removed from the repository. So in this case, we're going to actually commit our change, and it's going to make that deletion permanent. So git commit removed temp1 to demo rm. Right, git status. Our changes has been made permanent. Right, those 2 changes of removing the file can be combined with just git rm as opposed to just rm, right? That will remove the file and also add it for staging, so you can commit it right away. So you can do git rm temp2. Let's see. Did we remove temp2? No, we didn't remove temp2. So let's remove. Do we still have temp2? We do, right? Yeah. Okay. So we can do git rm temp2, and you'll notice that it removed it right away and added it for staging, right? That so it did it in 2 steps, right? It removed it and immediately added for staging. So that you don't have to do those 2 steps. It combines into 1. And you just have to now commit, make those changes permanent. Remove temp2 to demo git rm. Right, and our changes are now permanent. Make sense? Right. So you can do it in 2 steps or in just 1 single step. Git rm. Moving files, you can rename files. Typically, this will be considered by Git as a 2-step process, right? Meaning, if you rename the file, it'll freak out and say, "Ooh, I don't see the original file that was already there. You must have removed it, right? And there's this brand new file that wasn't there before that I don't know about, right? But not until we add it for staging is that it's going to realize that you didn't actually add a new file and remove an old file. You actually renamed it, right? So if we add a file, let's see, what do we have here? File 1, and I move it and I change its name, file1, and I change it to file-1.txt. If we do a git status, Git is going to report it as that you're removing a file that I knew about, file1. I don't see it anymore, right, in your local repository. And it will consider that this is a brand new file that I'm not tracking just yet, right? So it considers it being two different things. Not until you add it to the repository, it'll consider that it's renamed. It says, oh no, I see what happened, right? It'll see that it's the same exact file, and it'll start and it'll understand what it is. So if we do git add and do a git status, notice that now once it has been moved to staging, it then finally realizes that actually what happened is that we just renamed the same file that was already there just to a different name. And we can just commit those changes. So renamed file1 demo for MV demo. Right? All right. Or if you want to, instead of having these two steps, right, of first moving and then having to add into staging, you can just do it all in one single shot by just using git mv as opposed to just mv. Right? So git mv, you can change file number 2 to file2.txt. Right, and we do a git status. Notice that it immediately knows, it immediately makes the changes already in staging, right, as opposed to having those two steps. So let's commit rename file2 to demo git mv. Notice that we're being very verbose in our commits, right, and this is what we would expect from you as well. You know, as you make a change and it's an atomic change, right, that you would immediately commit that and be very verbose and you're very chatty, right, where you have lots and lots of distinct changes that can then be traced and much easier later on by someone else, right? You can see exactly what you did as you went through your commits. Control Z. Not really Control Z, but how about you've done something and you just realize that this is not what you meant to do, and you want to start backtracking to a previous state of the application. And for instance, you might have renamed something that you didn't mean to. You just want to go back to a previous version of your file. So for instance, we might have here on file number 3. You might have this this file that demo diff staging, and say you want to make a change, right? And for instance, you add a third line. Maybe we can echo third line to demo undo, and we append it to file 3, right? And we do a git diff. It'll say that we've added this brand new file, this brand new line at the end. So there's this change, and we just realized that we didn't mean to do this, right? And we want to backtrack our way. And I wish I just went back to the original content of the file, right? So that can be done very easily. You know, as you move the file closer and closer to the repo, it becomes harder and harder. Right now, the changes were made only on my working area, right? So it's very easy to just go back and undo what you just did. You can just check out, right? Just retrieve the content from the latest version in what is already in the repository, right? So checkout is going to copy, right, the very latest that is already in the repository and just going to overwrite anything that I have in my local working environment. Yes? So I can ask to check out file3.txt, right? And this just completely reverts my local changes, right? If I do a file3, notice that it doesn't have my third line there anymore. Okay? As you move the file closer to the repository and making it permanent, it becomes harder and harder, right? Or riskier and riskier, right? So first, make sure that you do a diff, right? That the changes that that you are about to make permanent are what you expect, right? That you haven't inadvertently made changes that you did not intend, right? So again, because it gets more involved the closer you put the file into staging and then into the repository. So that's one way. Now again, if you move your file into a staging, or you start moving it even into the repository, it becomes more and more involved, right? So for instance, this example here, we're going to move a file from our local working environment. We're going to move it to a staging, right? And to move it back, to undo the changes, and you realize that you just moved something. You added a file into staging, right? And you want to undo and go back to your previous state. So it's a little bit different. It's no longer going to come from our repository. Is that we're going to reset? We're going to ask Git to get it from the repository and just copy it into staging as opposed to our local environment, right? If you do a checkout, it's going to copy it to a local environment, right? But our change has already been made into staging, right? And so what we want to be able to do is to undo from our repository into our staging. So let's do that. So here we have our third file. Let's do our changes again. Let's echo our third line again into our file number 3, right? And we have file number 3 has changed, right? Notice that it has that third line to demo undo. Again, we can go back very easily here by checking it out, right? We check out file. We did that already. But say we're pretty confident that we want this change, and we start adding it to to stage. So we do a git add. So now our file is now in staging, right? It's ready to be committed, and we realize that we have 3 or 4 files that we're ready to commit, but we just realized that file number 3 actually no, that I don't want that change to go in. So how do? You could just undo the whole thing, or you can undo just individual changes. So for instance, this particular file, I want to go back to the previous version, right? The version that is already in the repository, and replace what's already there. So to do that, we need to use a different command. It says git reset. Git reset takes a pointer, right, to a particular version, right, from a particular commit, right, from or reference to a commit. Here we're telling it that to use head as the pointer, right, meaning the very latest that is already been committed to the repository, right, meaning, hey, take this file, okay, and whatever you already have permanent in your repository, I want to reset that file, the current file that is in staging, I want to reset it to whatever you originally had. So my original file didn't have that third line, yes? Right, my original file did not have that third line. And so I want to but my staging file does have that third line, yes? Right, so if I want to undo, basically I need to go to the head that has the original file without that third line and copy it onto my staging file. So let's do that. We can do a git reset head and that third line, third file. Right? So notice now it's unstaged, right? If we ask for status, it's kind of where we were earlier, right? Where we had added that third line, right? But we have not yet added it for staging. Now we can go back and make sure that we We can make the real modification that we want to do, and then add it to staging, and then for committing. Again, every time you get closer to the repository, it is a little more involved on how to commit these changes. Okay. If I want to completely undo what I had done, I could just check out the file again. Because notice that if I do a git diff, right, that change is still there. I can now I've unstaged the file, and I can check out the file so that go back to the original version that did not have that second line. Right, git status. Notice that now it's clean. There's no changes. I went back to where I was before I started all this. Yes? Right. All right. So what about if you went even further? Right. That you made the changes. You added it to staging, and even there you didn't realize that it's not what you wanted, and you actually commit, right? And you make your changes permanent. You still have the possibility to undo your changes before pushing it and making it and publishing it for everybody else to see, right? So to do that, again, it's a little more involved. The closer you make this more permanent, the harder it is to undo your changes and go back, right? But again, it's almost like putting it in the trash right before actually removing the file, right? You have different layers, right, of permanency that allow you to revert your changes. So, all right. So before we revert from the repo, let's look at some changes, some really soft changes that you can make. You might have made a commit, and you might have realized that your commit message wasn't as explanatory as you wanted it, and you don't want the TA to take points, right? So you might want to amend a commit instead of just just unchecking everything out and just throwing it away and starting all over. You already invested some effort at creating a commit with 3 or 4 files with some changes, a couple of lines of changes each, and you just want to amend it, right? So the amend command allows you to make minor changes to your commit. In particular, it allows you to change the message, right? The message that you had created. So let's go back and modify a file and create a wait a minute. Let me see. Here we have modified, and we have log. We added the file, and we're going to commit, and then change the commit. Okay, so all right, so let's go back and make the change again to our core file 3. Has been going back and forth, but make the changes. Right, and we have git status, and we're going to add it, and git add, and we're going to commit my very bad commit message, right? And I can amend it by saying git commit amend. Is that how you spell it? Amend, right? Yes. And I can change the message to change amend a commit so I don't lose points. Right. So it goes back and changes the log. So we can do a git log and see that my very bad commit message, right, has been modified to a much better explanation of what happened. Right? So you can always change something before you commit and send it over for other folks to take a look at it and start criticizing you or giving you positive feedback. You can also you know, if you have gone through the process of committing something and it's already in the repository, you might be tempted to say, "Oh my goodness, I've committed this. It looks awful, but it's already made permanent, right?" Don't fuss about it. Don't be tempted to perhaps get the repo at a particular state that would not show any of those changes, right? Just go back to the original file, make those fixes, and then do a new commit, right? Just if you have committed a file and then you realize that you have made a mistake, don't try to hide those changes and try to thwart the repository into somehow not having a log anywhere that you have made such a dumb mistake. Just check out the file again. Make the fixes that you seem pertinent, and then just create a brand new commit. All right. So for instance, if you had made a very bad change, right? That third line that we had added there in file number 3, we really shouldn't have done that. You can check it out. You can look at the log at the 1 line. Oops. Git fatal. Wait, what? Oh, sorry, 1 line. Notice you can go back to the history and you can check out the change, right, and make any changes by referring to any one of these SHA, right? These are unique enough that can refer to that particular commit, so that you can modify it, right, and then commit it again, right? So you can and so here, the example that we have here, it's let's see that git log is going back to the previous one, right? So for instance, we might have not wanted to notice that in this one, in the amend a commit, so I don't lose points. In that one, we had added the 3rd line, yes, to file number 3, and we realized that we shouldn't really have done that, right? We shouldn't have added that line. So I can go back to a previous commit, right? The one before I had made those changes, right? And do the changes that I should have gone in, and then recommit it back into the history. My changes will still be in the history, right? My really bad changes will be there, okay? But the commit that I'm going to commit after this one will undo those changes, right? So the full transformation of the file will be that my changes eventually won't be there. My really bad changes won't be there, right? But the history will be there, right? And so don't fuss about it. If you have made really bad changes, just go in, fix it, and then just recommit. So we can go back to our previous changes by checking out that particular commit before we had made those changes. So we can do a git checkout, right, and providing the actual commit number that we want to commit to, right? We're going to check out back in history, right? What this is going to do is going to move the head, right, and put our repository in the state that it was at the time of that one commit, right? In that case, file number 3 had not been changed just yet. Yes, right? We can also tell it from a particular branch and a particular file. So that we have the commit, the branch is master, and the file is file 3, right? Oops. Is it dash dash? Or just file 3? Okay, there it is. if I take a look at the file 3, notice that it does not have that third line in there. See that? It's no longer there. So we have file number 3 in the state that it was at that particular checkout, right? Notice that it differs from what the version of head has, right? If we ask for the difference, oh no, I'm sorry, it has been staged already. I'm sorry, it has been staged already, and it has reverted it back to whatever file 3 was at that particular checkout, at that particular commit ID, and we can just make that change permanent. So we did with undo changes to file 3 to demo checkout a previous commit, right? And then we can, and there it is. So we have now put file number 3 back the way it was, right, from a previous checkout. So you can do it individually, right, or you can do it back into an entire repository, and we can look at that as well. So yeah, so different mechanisms to undo, right, any changes that you might have discovered that were inadvertent changes. Or you can revert to a previous commit and just literally move reset the entire stage to a previous version by reverting it to a particular version. So this will revert the entire working set, right, to all the files back to what a particular commit was. Before we did it to an individual file, right, but you can revert an entire to a previous commit so that all the files, right, are going to be replaced by a particular previous commit, right? And the same thing, you do a git revert and then provide the ID of that commit value. And finally, one of the more dangerous ones is reset, right? And again, you can provide the ID of from a particular commit that you want to change to. One of them is it'll literally move the head, right, the pointer that is pointing to the top, the latest commit. It'll move it around, right, and put it wherever you want it, right? And do different things to the other two environments, right, the staging environment and your local working directory. The soft, depending on the reset type, the soft will not touch your working environment and your staging environment, right? It will move the head, right, and point it to wherever you want to point it to, and any differences, any file differences will be reported to you, saying, yes, you moved the head, and the local environment, your local files differ now from the head. What do you want to do? Do you want to commit those changes? Do you want to make some changes before putting it there? Or it'll if you use mixed, it'll move the head and it will make staging the same value as what the repo is, and any changes to the working environment will be reported to you as what is that you want to do with the changes that you have in your local environment. Or hard will just change everything, right? It will move the head, and your staging and your working environment will look exactly like it was at a particular pointer, when you move head. So this one's really dangerous. Be careful when you move things around, and we need to leave it there. We'll come back and finish it up on Thursday. All right, thank you.